Right, so I'm going to do a quick mini example using the timer. Um, like, okay, let me just go to simulations and go to input output. And you can access the timers or counters using this tab right here. And then I'll be working with a timer on delay. So this is TON, and I'll drag it and simply drop it. So before I start, I'm going to go over the parameters of TON. So TON stands for timer on delay, and we have timer over here. And timer is basically the address assigned to the timer, and we can use any address from T40 to T499. So you have around um like 99 timers you can use. You also have time base, which is the factor to calculate the total time delay. For example, it's 0 0.1 over here, and I'm actually going to set my address to be T4 1. That is my address. And my third parameter is preset, which is the time duration before the output activates. For example, if we set the value of preset to be 100, 100 times 0 0.1 is going to be 10 seconds. So my timer will activate, my output will activate after 10 seconds. We also have accum, which is accumulated value. So it displays the current elapsed time in which the timer is counting. So I'm going to do a quick mini project on um, energizing a lamp after 10 seconds after pressing a toggle switch. So for that, I'm just simply going to drag, flip this again. Um, there you go, to go to user. And I'll drag a toggle switch, and I'll have a normally open contact, and I'll drag the toggle switch right here, and I will edit this to be toggle. Essentially, after we press the toggle switch, the timer starts running, and we are going to use the outputs. Oh, I forgot to introduce these two outputs. So we have EN, which stands for enable bit. It turns on whenever the input is energized. And we have the DN, which stands for done bit. It turns on after the accumulated time has is equal to the signal time. So basically, after this accumulated time has finished accumulating over the setting time, this bit will turn on high. And we want to use this bit to turn on the lamp after 10 seconds. So I'll drag another normally open input, and I'll drag the address of DN right here. Oh, or actually, so I'll rename this to be T4 1 over DN, which means that T 1 is our timer address itself, and we're going to use the done bit, so we'll be using DN. And I will rename this to be timer output. And after this timer has run out, has finished running, I will energize this lamp, and I'll drag this lamp address over here, and I'll edit this to be lamp. So let's see this in action. I'll download the code and I'll run it. So essentially, after I press the toggle switch, my timer starts running, as you can see over here, and it starts accumulating. And right now you can see my end bit is high, but after my time has been accumulated to this preset number, it will turn on my lamp. And once I release my toggle bit, it will reset the timer as well as turn off the lamp, like right here. So like, as you can see, my accumulated time is 0. And if I want, I can turn on the toggle switch and release my hand. Like if I release my hand before the certain time has, before the setting time, my lamp will not turn on. So as you can see, I press on it, and right before you can see the time is accumulating, and even before it accumulates to be 100, if I release the toggle switch, my lamp doesn't get turned on. So in order to turn on the lamp, I need to let it run for 10 seconds. And then after 10 seconds, my lamp turns on. So that is on toggle, that is on more on timer on delay. Now I'm going to be working with timer off delay, and you can access that by TOF here, which is timer off delay, and I'll drag that. So before I begin working with this, I'm going to introduce the parameters. These parameters are very similar to TON, which is timer on delay that I mentioned earlier, where we have our timer, which stands for the address of the timer itself. So you can use any number from T41 to T499. We also have our timer base, which is a factor used to calculate the total delay time. Our preset number, which is the set time duration before the output turns off. And for example, if we set this preset number to be 90, we can multiply that number by 0.1 to get 9, which is our delay time, which is going to be 9 seconds. Our accumulated time, or ACCUM, displays the elapsed time while the timer is counting. So I'll quickly go ahead and start with the address first. So I want this address to be T4:1, and I will have my preset number to be 90. And I also want to do a mini project where I want to keep a lamp energized for 9 seconds after I switch off the toggle switch. So it's very similar to what I did in the first project. However, this time, once I turn on the toggle switch, my lamp will energize, and after I turn off the toggle switch, it will continue to energize until for 9 seconds, which is our preset number right here. And we can do that by simply dragging a normally open contact, which will be my toggle switch. And I'll rename this to be toggle. We're going to be using these outputs. We have our enable bit, which turns on whenever the timer input is energized, so whenever I turn on my toggle switch. And we also have our done bit, which turns on as long as the timer input is high, and when the input goes low, it stays on until the timer finishes off its timer delay. So which means that once I press this toggle switch, it stays on, and once I release it, it stays on for a certain amount of time until after that it turns off. So I will drag a normally open contact right here, which will be for my done bit over here, and I'm going to change the address to be T4:1, which is going to be my address of the timer itself, and I want the done bit, so I will have DN, and this will be my timer output. And once this goes on, I want to turn on a lamp. And I'll drag a output coil and drag the address of the lamp right here. And I'll rename this to be lamp. Alright, so I can simply download the code and run it. So as you can see, once I press the toggle switch, my lamp automatically turns on, which was not the case for a TON switch where we have to wait 10 seconds. But right now, the lamp automatically turns on. And as you can see, the timer has not gone off yet. However, once I release this toggle switch, you can see that the timer starts going on. And my lamp still stays energized until this accumulated time hits 90. And then my lamp turns off. And the same thing where I can turn on the switch and my lamp energizes, and I release it and it stays on for 90 seconds or for 9 seconds. And that is timer off delay. Now, the third kind of timer would be the RTO timer, which is this right here, and I'm going to drag it. And as for the parameters of the timer, it is very similar to the TON and TOF that we talked about, where the timer is the address of the timer, So we can use any address from T4.1 to T4.99. And the timer base is the factor to calculate the total delay time. And the preset value, which is this one right here, is the set time duration before the output turns on. And the accumulated time, it displays the total time accumulated. However, unlike TON and TOF timers, the RTO timer doesn't automatically reset. So if you call back a while back, if we started the toggle switch and we turned it off, the timer would reset. But in the RTO timer, it retains this value, and even when the input goes low. And as for our outputs, we have our EN and DN. So EN turns on whenever the timer input is energized, and DN turns on whenever the accumulated time is equal to the preset value. Kind of very similar to TON, except TON kind of resets after the input goes low. But over here, it retains that value. And I'm going to do a mini retentive lamp delay project. And in order to do that, I'm simply going to start by dragging a normally open contact. And I'll have my toggle switch. So I'll drag the address of the toggle switch up. And I'll rename this to be toggle. And I'm going to then change this address to be T4:1. And I'll set the preset number to be 100. Means that I want this timer delay to be 10 seconds because 100 times 0.1 is 10. And I will drag another normally open contact, and I want this to control the lamp. So I will drag an output coil, and I'll drag the address of this lamp here, and over here I will drag I'll type the address of the done bit, which would be T4:1/DN, because I want to use the done bit. And I'm just going to rename this to be timer output, and then this to be lamp. Alright, so I'm going to show you how it works now. I'll download the code and then. So once I press the toggle switch, my timer starts going on and it starts accumulating the time. However, if I release it, it still holds on to that value and it retains that number. So once I press on it, it starts counting, and once I release it, it stops counting. However, it still retains that value. And after this accumulated time has reached 100, my done bit turns high, which means that my lamp turns on. And as you can see, if I release my toggle switch, because my timer doesn't get reset, my lamp continues to stay on. And this is because the retentive timers required a separate reset button. So in order to reset that, we can simply go here and go to timers, and we will use this reset button to manually reset the timer. So we can drag that. And for example, let's say that if I click this start switch, it will reset that button. So I'll have a normally open contact. So I will copy the address of this and just change this to reset button. And I want to reset this timer. So I'll copy the address of that timer right here. So that would be T4:1. And essentially what that means is that once I press this start button, it will reset the timer. So let's see this in action. I'll download the code and run it. So as you can see, since the timer has already reached that accumulated value, it keeps growing, and my done bit is still energized, and my lamp is also still energized. So in order to reset it, I can press onto the start button, and as you can see, this accumulated time is 0 now, which means that my timer has successfully been reset. So after I start the toggle, I press on the toggle switch. As you can see, if I press the start switch, it automatically resets the timer, even if my toggle switch is on. And I can continue doing that, and it keeps on counting because my toggle switch is on. So I will turn that off, and once I press it, it will reset. So in order to turn on the lamp, I just need the accumulated number to be 100, which is 10 seconds, for my lamp to finally turn on. And I can turn that off, and my lamp will continue to stay energized.